Okay, welcome everyone. This is a 1-hour presentation entitled Texture Baking with 3ds Max. My name is Brian Smith. This is a sample presentation of one of the subjects that is taught at the CG School. This particular subject is taught during the 3ds Max portion, our 3ds Max class, and it's discussed also during some of the other classes such as Mental Ray and V-Ray. But this is just a demonstration. For more information on other classes and this particular subject, visit thecgschool.com. This class is being recorded, so if you are watching this, if you're registered, you will receive an email at some point, probably next week, when all 5 of these presentations for this week, this free week, are completed. So you should be receiving an email next week with a link to allow you to re-watch this at your leisure. Before I get started, I want to mention that there are 2 files that I'm going to be using. If you want to download these files right now or at some point later, you can download them right now at this address, www.thecgschool.com/R as in Romeo 2 T as in Tango .zip, R2T.zip, which stands for render to texture. So you can download those right now, or if you're watching this later, sometime after it's been recorded, you will have the link or the support files provided in the download that you watch at a future date. So with that, we will go ahead and get started. So what is render to texture? Render to texture is a technique that's been around since 3D has been around. It's used, unfortunately, it's really used just, for the most part, just in the entertainment industry, specifically the gaming industry. It's a technique whereby you bake textures into your scene so that you don't have to create and calculate GI, shadows, lighting in real time, and it's a really useful technique in those game solutions. If you did not have texture baking, you would not have the type of graphics quality that you have in your games, because computers even today simply could not keep up with the type of lighting that you see baked into your scenes. You could not calculate that with most computers or most workstations. So this technique allows you to do all the work ahead of time, bake it into your materials, bake the materials into your objects, and then watch them as if those elements are being created in real time, which they're simply not. So we're going to go through this process of setting it up for a really simple scene and then a little bit more complex scene, but do understand that this is a live presentation. This has to be the enormity of the scenes, and the amount of work that we do here has to be constrained to some degree. So we're going to start on a very, very simple scene, move on to a little bit more complex scene, and I'll discuss how you would implement this type of thing on more detailed scenes. One more thing to mention, this particular technique is not for all your scenes. It simply would not make sense to do texture baking if your final product were only one simple image. If you were just trying to create one nice high-resolution image, one view, or even just a couple views, it wouldn't be worth it. It becomes worth it when you have a specific need. You need to do an animation. You have a lot of different views to capture. You want to be able to show your client in real time your camera moving around your scene with all the proper GI, all the proper shadows, which you really can't do if you don't have those textures baked into your objects. You simply can't do that through your viewports. Looking through a typical viewport, for example, here is that first simple scene we're going to be looking at. This is nothing more than a box sitting on top of a plane. As simple as the scene is, I can't introduce complex lighting and shadows and GI into the scene. I can't illuminate these areas in shadow without GI in my viewport, and I can't implement GI in my viewport unless I do something like radiosity, which is one of the first forms of GI that you still find in 3ds Max, but it's really outdated and you really shouldn't be using it for the most part, except for implementing some GI into your viewports. But I don't have GI in this viewport, which is why I'm seeing complete black in areas of shadow. Well, if I were to use texture baking, render my scene out with texture baking, and then use those textures where I currently see darkness, I would, instead of seeing darkness, I would see the proper light and the proper shadows. And once the texture baking is complete, you can turn off your lights, you can turn off your GI, you can turn off all those things that allow you to produce the final image that takes so long to produce, and then render your scene in seconds. A simple scene like this is going to render in seconds anyway, but if you imagine this to be a complex scene with thousands of objects and hundreds of lights and just a really complex scene that takes an hour or two to render, once you texture bake it and apply those textures to the objects, turn off the lights, turn off the GI, turn off all those other complex elements. Once you do that, you could render a scene that could take a few hours to render, could literally take a few seconds to render, or more practically probably a few minutes, because you still have things like image sampling to produce. You still have to process those pixels. So I'm not trying to say that you can render millions of polygons in seconds. It's not typically that efficient, but needless to say, you could seriously cut your render time down to a very small fraction of the final render time, something on the order of 1%, and that's pretty significant. So let's go ahead and get started. This is a simple scene with a plane, a box, and a V-Ray sun. I'm using V-Ray here, but the process that I'm using, the steps I'm using will be exactly the same regardless of whether it's V-Ray or Mental Ray or some other render engine. So there is a keyboard shortcut to execute the render to texture dialog box, and that is 0. So if I hit 0, I get the render to texture dialog box. Now, probably before I go any farther, let's do a quick render to show what this scene looks like. And I intentionally set the scene with very high render settings just to show that this scene does, I wanted to make the scene take more than just a couple seconds to render. So I wanted it to be something on the order of 20 seconds so that when I do render to texture, you can see how faster that is. If I had this render too quickly, you wouldn't see any difference. So that took 19 seconds to render. So I'm going to try to shoot for something like this with render to texture, and I'm going to try to do it in just 1 or 2 seconds, something like that. So if you multiply this by this image or this rendered product by a lot of time, several minutes, or even a few hours, you can see that you can save some time. So here's the render to texture dialog box. We have a general settings rollout, an objects to bake rollout, output, bake material, and automatic wrapping. Let's start at the top, general settings. So when we render to texture, we have to produce maps. We have to produce textures. So those textures have to be stored somewhere, and this is where, by default, I'm going to place those textures once they are rendered. Okay, I also have a render setting area where I can use some presets. I don't have any presets stored on this machine for V-Ray, but if I did, I could load them up right here. I could also open up the render scene dialog box using the setup button here. And I can also use network render here, which I won't. Speaking of network render, you could render to network. I'm not here. I'm using a single machine. It's a mobile workstation. It's a pretty sweet setup. It's a mobile workstation from Box Computers. It's actually a 12-core machine. So if I go into the task manager and look at the performance, you would actually see 12 processors on this. So you'll see 12 buckets rendering. And this is essentially a laptop, but Box Computers would hate for me to call it a laptop. They call it a mobile workstation, so it has a workstation processor and motherboard on it. So needless to say, it's a pretty fast setup. You don't want to really try render to texture on something like a simple Core 2 Duo or something really small. If you do, you're probably not going to be able to handle some very large scenes. Okay, objects to bake. I could hit Control A, select all the objects in my scene, but I'm only going to get those objects inside this Objects to Bake section that can actually be baked. I can't obviously bake a light, so you won't see that selected here. So if you want to select all your objects in your scene, the simple thing to do would be to hit Control A. Or you can just individually select the objects that you want to bake. I do not have to bake all my objects at once. And if you're using a machine that is not capable of baking your entire scene all at once, then there's no problem whatsoever selecting one of your objects, baking them one at a time, and then moving on to the next object. And when you're talking about some very large complex scenes, which is primarily what you're going to do this for, you're probably going to need to on occasion you're going to on occasion need to do incremental render to textures where you select one object, bake that texture, select the next object, bake it. But this is a simple scene, so I'll just select both of these objects. You can also set up a preset where you have all the settings in here in this dialog box set up automatically. I'm not going to worry about that right now. I've just got two objects selected, box 001, plane 001, and selected object settings. This can be left as it is. I don't see any need to change this at any time. Projection mapping, that is another class in and of itself. I don't have time to go into that. That would be things that deal with normal mapping. If you haven't ever looked at normal mapping, definitely take a look at that. That's when you have a complex object. You create a normal map from that and then use a smaller, lower polygon version of that object with the normal map to render your objects faster looking the same way. So let's just say you had a really complex looking spaceship with all kinds of detail and a million polygons. You render a normal map of that and then replace that spaceship with a 1,000 polygon version of it using the normal map attached to it. So that 1,000 polygon normal mapped object can look just as detailed as the 1,000,000 polygon map that took a lot longer to render. And by doing that, you can render your lower polygon version much faster. So look into that if you want to expand your use of render to texture. Mapping coordinates. This is something that you need to make sure you have set to use automatic unwrap. I can't remember. I believe the existing channel is what's automatically set. If it is, make sure that you set it to use automatic unwrap. And a lot of these settings that you see will be set to something other than default. What you see here will be set to something other than default because once you use render to texture with certain settings, unless you close Max and reload it, you're going to see those same settings enabled. So make sure it's set to use automatic unwrap. Let's go into the output rollout. And here is where you actually tell Max or V-Ray what type of map you want to produce. Simply click the Add button, and here are all the different texture elements that you can render to. These at the top are what you see because of 3ds Max. You will always see these in 3ds Max, and the stuff at the bottom are V-Ray specific. V-Ray's version of these things at the top. So for example, if I wasn't using V-Ray, if I was just using, Mental Ray or some scanline version, I could use Complete Map, but V-Ray's version of that is V-Ray Complete Map. There are a lot of different options: caustics, total lighting, bump, normals, and there are specific reasons why you would use some other things like normals map. I was just talking before about projection mapping and normal mapping. That would be an instance where you would use something like that. But for the most part, most of your scenes that you use render to texture with are going to require the complete map. And if you do not use V-Ray, this would be your option here, just regular complete map. That instead of computing or rendering to texture just a certain portion of the lighting, for example, the raw lighting, instead it's going to create a texture of all the lighting components and all the lighting elements combined, which is what you see in the final render product. So needless to say, I want to select V-Ray Complete Map, so I just double-click that. And then I have this section down here under Target Map Slot where it says where do you want to actually put these this map? Well, notice it says ambient, diffuse, specular. This looks an awful lot like what you would see in a standard material. If I go into a standard material, look at the maps channels, I see ambient, diffuse, specular, specular level. So these different map channels are the types of map channels that you see right here. So it's asking you, once you create this V-Ray complete map, where do you want to store it? When you create that map, what channel do you want to put that map into? Well, for the most part, I will always select self-illumination, and I'll explain why in a minute. And I'm going to be going through these steps at least 2 or 3 more times, so if you're not able to keep up, you can see this again a few more times. You can watch this video later. But needless to say, right now I'm just going to select self-illumination. And next, you can set your map size to a certain specific amount here, or you can use presets over here. Your map is going to be square. You can't really, you really need to have a square map. So I'm just going to use one of the presets here. The default is 256 by 256. Let's go with something a little bit higher, like 1024 by 1024. Now, if you have color mapping applied in your scene, which I do, and you would see color mapping inside V-Ray right here, I have exponential color mapping, and that exponential color mapping is changing the appearance of my final rendered image. And if I have it in here, then I probably should apply it right here. That simply means whatever color mapping you have enabled here, bake it into your scene. If I didn't have that here, if I didn't select this checkbox here, then once I have the render texture set and ready to go, I would need to leave color mapping set here. And it really doesn't matter which you do, but I'm going to enable this here, and you'll see once I'm done rendering the texture, I'm going to take this off exponential and put it back to linear with default values, because linear with default values is essentially no color mapping. It's essentially not changing your final rendered image in any way other than the default, what V-Ray would call photorealistic or physical lighting, correct physical lighting. So I'm going to set this to color mapping. Next, we have baked material rollout. And I believe the default value here is duplicate source to baked. I don't want to duplicate source to baked. I want to create a new baked material, which simply means if I open up the material editor, I will see a new material in this scene, and I will see the new material applied to the object as opposed to manipulating the old object. Needless to say, I suggest using create new baked material. You have different options, all the same kind of options you would have for a new material. I'm going to leave this set to blend. That is the default material for a standard material. It's the default material quality for a standard material. And I might explain some of these other settings in a moment, but that's enough for right now. Let's go ahead and get this process started, and we'll go back and look and see what actually happened. Under automatic unwrapping, there are some more complex things. We won't get into that at this moment. But down here at the bottom, we see render, unwrap only, or close. And we also see original and baked. We're going to create a shell material. And if you're not familiar with the shell material, notice that it says here, save source as a shell material. If you're not familiar with the shell material, it just simply allows you to show a original material and a baked material and have one show up in the viewport and another one show up in the final rendered image. I want to set this baked material to be visible in the viewport and the render. If I set both of these to original, then it simply means that the original material, not the baked material, the original material will be what is shown in the viewport and what is shown in the render. I want the new baked material to show up in the viewport so I can use it to show my client as I'm moving around the scene. Here's the complete scene with GI and everything else, and I also want to show it in the render scene in the rendered image. So I don't know why these aren't set to both of these options by default, but they're not. The render option is set to original by default. So I'm going to leave these both to render for baked. And then I'll go ahead and click render. And now what you'll see is a status indicator saying how far along we are into baking textures. And while I am processing these images, the audio might be graded a little bit, so I'll minimize the amount of talking that I do while the actual rendering is taking place. So we'll just let this render for a moment. As I mentioned before, I intentionally set these settings to be very high because they're very high. It's taking a little bit longer to render, but that's exactly what I wanted, and I wanted to show once this texture is completed how quickly the texture-baked scene will render. So this is the first material that is being rendered, and the next material, this is the first object to be rendered. This is the plane object. The next object to be rendered is the actual box itself. Okay, so we have both objects now baked. So what you're looking at when you see this layout is the unwrap UVW, or the UVW unwrap modifier, going to work automatically, unwrapping this object or each individual object, and it would be the same unwrap modifier that you would see down here under unwrap UVW. So that's being applied automatically. The objects are being unwrapped. The objects, once unwrapped, are being rendered. Those renderings are saved to an image. Those images are saved to the desktop, in this case my desktop. And if I were to open up one of these, let's open up this object inside Photoshop. If you open this up in Photoshop, there is the rendered texture. So this texture is now applied to the plane object, the plane in my scene, and I can turn off the lights, turn off the GI, and everything else, and I will see the same product with a fraction of the render time. So let's go ahead and close this dialog box out. Now this doesn't look like the final rendered image because by default you're going to get the materials that you previously had replaced with these stand-in materials. What I do now is go to a new sample slot, and let's click on the pick material from object eyedropper and click on this red box. Now it looks like a red box. It has a shell material on it. The shell material again has an original material and a baked material. I can see the original material inside my viewport and inside my renderer, or I can see the baked material inside my viewport and inside my renderer. So this red material is a temporary stand-in. Let's go into this baked material, and there's two quick simple steps that I have to do once I'm in here. First, remember how I set this to self-illumination. I want this map that is in my self-illumination to actually be used. The map is already in there because I told it once I create that map, throw it into the self-illumination channel, which it is, but once it's in there, I have to actually activate it. So I activate it, and once I activate it, I want to show that map inside the viewport. I want to see this inside the viewport, so I show standard map in viewport. So there's my standard map. Notice also that this material seems to have a red hue to it. That's simply because of this ambient and diffuse color that's applied to it. Self-illumination, if you don't know, is a material quality that prevents shadows from falling on an object. So if I have a white light bulb, I'm trying to make an object look like a white light bulb. If I set self-illumination to pure white, then no matter how dark my scene is, that object will appear to be white. Well, this color means nothing once I have a map loaded, which I do, so the map dictates the color or brightness of this self-illumination map. So whatever I see in the self-illumination channel, this map here, whatever I see in here is what I will see inside my viewport no matter how dark my scene is. I could take all the lights out of my scene and I will see this map in my viewport. However, if I have something in diffuse and ambient that is brighter than those parts of the map that are being viewed, then that will overshadow those colors. If I had pure white on all these sides of the box, then I wouldn't see that red color because the red is not as bright as the white. But since the colors that I have are not as bright as the red in some cases, I need to turn down diffuse and ambient to pure black. And it's just a good idea to do that all the time anyway. Okay. Next, I want to do the same thing for my plane material. So I need to go into another empty sample slot, pick material from object, click on that object. There we have our initial view. I need to go into the baked material. I need to go and activate self-illumination, go into that map, and turn on Show Map in Viewport. And this Show Map in Viewport, by the way, won't affect the final rendered image. This is just so I can see the map inside my viewport and show the client proper GI and lighting without having to render. Once again, change the ambient and diffuse so that it is pure black, and this is what I get. Now, if I move around my scene, I really don't see proper lighting. If I hit Control L to take viewport lighting off, that simply means instead of seeing lighting dictated by the lights in my scene, specifically this V-ray sun, I want to hit Control L to divert back to default lighting, and that simply notice how that shadow over here appears no matter what. That is the shadow that I get with default lighting. Default lighting is where you have a light in front of you and behind you and off to the side. So I can turn off viewport shadows if I wanted to. I could go over to somewhere in here, lighting and shadows. I could turn off shadows and get rid of that shadow there and be left with just the shadow that's baked into the scene. I could also now select my light, turn off this light, but an easier way inside V-Ray would be to go into the global switches rollout and turn off lights. Whether you do this here or in Mental Ray or some other render engine, it doesn't matter, but I just want to make sure lights are off no matter what my GI configuration is. So I want to set this to off, and I need to turn off GI. I disable GI because I don't need it anymore. I already have it baked into my scene. And finally, since I included color mapping in my texture baking, I need to set my color mapping here to linear. That gives me the default linear, which won't manipulate my final image whatsoever. So again, this is all to get rid of lights, to get rid of shadows, to get rid of GI, and get rid of color mapping. Now, I still have this image sampler to deal with. This image sampler still has to be set to a reasonably decent value in order to get a good quality rendered image. If I didn't have image sampling set correctly, no matter what my other settings were set to, I could really screw up my final rendered image. So I'm not going to change the image sampler. I could if I wanted to, but it would be pointless to render the texture with a high quality image sampler and then take it down to a lower quality image sampler. That would just be ridiculous. So you would at least set it to something as good, if not better. You could always do an image sampler with something low quality like adaptive subdivision, which is a good test render setting. You could render to texture with adaptive subdivision, which would mean the render to texture will happen a lot faster, and then during the final rendered image, which happens much quicker, you can set it to a higher quality image sampler. Regardless, I'm just going to leave the set to adaptive DMC, which is a good quality image sampler. I have, if you know V-Ray, these settings are decent image sampler settings. So needless to say, GI is gone, the lights are gone, the shadows are gone, color mapping is gone, and I'm left with just the final render image. So if I render this right now, it should just take a moment to render, and it took 3 seconds to render, and that 3 seconds was mainly due to the image sampler. If I use a lower quality image sampler, that image sampler this image could be rendered in less than a second in some cases. So we have a final render image. For the most part, it looks high quality enough. The only issue that I see here that I'm not happy with is this light that you see down here, this light leaking that you see here. There's a few ways to deal with that. I won't discuss this right now, but we'll get to that shortly. But this is the final render image. This is a textured bake image. I can see this fairly decently anywhere in my view, and I'm seeing shadows and I'm seeing GI. Okay, so let's go through this one more time with this scene, and then I'll go into more complex scene. I'm going to reopen this scene, simple box. I'm going to go through this one more time with the knowledge that we already have, and we'll run through the steps one more time. So we have a location. We need to select all the objects in the scene. Control A or window all the objects is fine. Select all the objects. Use automatic unwrapping because we want to automatically unwrap these objects. We want to create a map, so we're going to have to add, under the output section, we need to add a V-Ray complete map or standard complete map, whichever. Double click this. And I want to set this to self-illumination. Remember, self-illumination is what that map got loaded into automatically. If I selected diffuse color, that is a little more difficult to deal with, because if I have this same map inside my diffuse channel, let's create a standard material. If I have this diffuse map, render to texture map inside the diffuse channel, that's fine. That's going to show me what I need in the diffuse channel, but then I have to worry about lighting that diffuse channel. The diffuse channel is only going to be visible if you have diffuse lighting, if you have lights. Well, if I have lights, that's going to take longer to calculate, but besides that, it's going to be hard to make sure that that light has the proper illumination, because if I don't set that light to just a certain setting, it's going to blow out the diffuse lighting map that I have. So it's really almost pointless to use the map inside the diffuse channel, because you have to work very meticulously with the lighting to get it to look properly. You could, and there's some instances where you would want to have that control, but for the most part, you really want to load this up into self-illumination so that no matter what your lighting looks like, you're going to see what you see in that self-illuminated map. Okay, so that is set to self-illumination. Let's set this next one to something lower, like 256. We'll leave that. Set to 256. Apply color mapping. We want to create a shell material, a new shell material. So we want to save the source as a new shell material and create that new shell material as a standard blend. I believe this is set to duplicate source to baked. We want to set it to create new baked blend. Okay. And we want to set the view and render to baked. So the viewport and the rendered image will be set to baked. Render again. And that scene will render much faster because it's a much smaller image to render. The lower resolution you use, the less detail you're going to have in your objects, the less detail you will have in your scene. Notice the lighting around the base of this side of the box here is a little less accurate. It's constrained by the resolution of the map, so you can only save so much detail into this map. Okay, so there's our second object baked. I'm going to go into the material editor, go to a new sample slot, and load each of these objects into new sample slots. So I have these two objects here. I have a shell material, original material, and a baked material. I need to go into the baked material and do two things. I need to set up self-illumination. So I need to click on self-illumination and change it so I can see this map inside the viewport. And I need to set the diffuse and ambient to pure black. So there's one material down. Go into the next material, enable self-illumination, enable the show map in viewport, go out into the parent material and set diffuse and ambient to pure black. Once I do this, I have to change the lighting. To get rid of the lighting, I have to disable lights. I need to turn off GI, and I need to turn off color mapping. I can't really turn off color mapping, but I set it to linear because that is essentially no color mapping. Once I do that, I see that I still have some black in my shadows. That's because I'm using viewport lighting. I'm using the lighting dictated by this light here in my scene. So I hit Control L to go to the type of lighting where it's not dictated by the lights in my scene. Okay. So now I see shadows baked into my materials, and no matter where I view this from, I will see a decent, proper looking image. Let's close the material editor, close render to texture, render. Now the problem I have here is the quality of this map. Because of the low resolution of the map, it didn't know how to handle this interaction between the box and the plane properly, and you're getting what appears to be light leaks or some sort of odd GI. So you have to have decent quality maps to work with in order to do this. And if I decided that one object in here was sufficient to render at 256 by 256 and another object wasn't, that would be a case where I would render one object to texture at a certain resolution and then render the next object at a separate resolution, and there's nothing wrong with that. The more detailed your objects, or I should say the more detailed and the more visible those objects are, the higher resolution you will need or want on your textures. One more really cool thing before we go any farther. I have these maps inside my desktop. If I were to go into the plane map, let's go into, well, it looks like I already have this map open. Let's update this. Okay, so here's my plane map. If I go into this map and change this map in some way, I will see those changes show up inside my viewport. So really quickly and simply, let's draw something inside this viewport. Let's use a bright blue color. Change my paintbrush to something bigger. If I were to just draw a blue line around this box and save this, go back into Max, I see that blue show up inside my viewport. And this is the essence, or this is the whole foundation behind what's the term I'm looking for? Material texture painting. This is the essence behind texture painting, where you have a material that's unwrapped and you paint your textures however you want. This is how really high quality images or really high quality maps are produced inside award-winning visualizations. Even if you don't use texture baking, the process of unwrapping your objects, like what happens automatically behind the scenes with texture baking, this automatic flatten UVWs, which is essentially the same thing as UVW unwrap, this process where you unwrap your objects so that you can create textures and paint on those, save them back to the objects. This is the essence behind all this. So all these changes I make here, once I save them, get updated automatically inside Max. So it's a pretty cool way to work. And this is how you can really do some pretty cool textures and get, remove problems like seams in your textures. If you have seams and you're trying to get rid of them, well, you can get rid of them very easily and add some really cool detail and dirt and graffiti and all types of, interesting material characteristics like aging to your materials quite easily with this process. So that is essentially texture painting. Let's go into a different scene. Let's go into the other one saved for this, Savannah Interior. And again, I mentioned this at the start of the webinar. If you weren't here at the very start, I mentioned that both of these scenes are available here at www.thecgschool.com/r2t render to texture.zip. Okay, and these will be available in the download that comes next week. Once all 5 of these free classes are available next week, you'll be able to download this later. Okay, so here's our slightly more complex scene, pretty simple scene 2. It's an interior scene. We have a V-ray sun shining through the windows of a patio into the interior of the scene. If I go into the camera view, this is what I see. I'll turn on faceted mode. You can see the objects we have. I have 3 fill lights. I have one behind me pointed towards the interior. I have one inside this door and one above the kitchen. There's no furniture in the scene. It's a very simple scene. It's got 53,000 polygons, and it renders fairly quickly. If I just hit the render button right now, it will render in about 7-8 seconds. So nothing really complex at all. And I want this to render fairly quickly, so there is some noise, there is some lack of detail, so it's not certainly the best, but it demonstrates what I need to demonstrate here. So we're going to produce something similar using render to texture, and once we do, we can move around the scene, move around, do whatever we want, and no matter where we view the scene from, we will see a decent looking rendered to texture image. Okay, same process that we used before. I need to go into the render to texture dialog box, so hit 0 to open this dialog box up. I want to save this to my desktop, and I want to select the objects to bake. Now, I can bake all these objects again, or I can bake one at a time. I want to select, there's 3 main objects in the scene. The first object is, if I hit Alt-Q, you can see the first object is the walls, floor, and ceiling. So it says walls, but it's really all these objects are one. And inside the material editor, you would see that there is a multi-sub-object material applied where I have one material for the wall, one for the ceiling, one for the floor. Regardless, this is all just one object. Okay, and I want to turn all these back on. Okay, so I want to select the walls and also the floorboards. So I have walls and floorboards, and I think I inadvertently changed the name of the walls to M by typing in M for material editor. So disregard the fact that it's labeled M. It should be called walls. So we have walls and baseboard. And let's go down into the mapping coordinates. We need to make sure use automatic unwrap is enabled because we want these objects to be unwrapped automatically behind the scenes. I need to click on add so that I can add a V-Ray complete map. So I double click V-Ray complete map. Once I do that, I see this target map slot open up where I can add the maps as self-illumination maps, or I can add them in the self-illumination channel, so I will do that. And let's use 512, 512 to start with. Let's apply color mapping because we want to bake the color mapping into the texture. Notice these settings are pretty much set up the way they were before. These aren't the default settings, but they are left from the last time we used this render to texture. I need to make sure this is set to create new baked standard blend. I want to create a new blend material with these maps loaded in, and that's it. Other than setting the render to baked, I want to have baked show up in the renderer. I can go ahead and click render, and here are my textures baking. There's the first, and there's the second. Now this rendered very quickly because I still used very low quality render settings. I'm in V-Ray, and you don't need to know anything about a V-Ray, but needless to say I'm using very low quality GI, light cache with 100 subdivisions, irradiance map set to very low, and I'm also using a adaptive subdivision for the image sampler. So this rendered very quickly, but it's just important to understand that I'm only doing this very quickly for the demonstration purposes. If this scene were a very complex scene with lots of furniture and thousands or millions of polygons, this would take a lot longer than just a few seconds. So not a big deal there. I have this blue material applied to my walls and red or purple material applied to the floorboards. Why is that? Because it creates a generic material in its place, and I need to replace those materials. So what do? I need to go into an empty sample slot, click the material, pick material from object, find that material, get it off of the object onto the empty sample slot. Do the same thing with the baseboards. So we got our baseboards and our wall material. Now I need to go into that baked material and do the same thing I did before. I need to activate self-illumination, go into that map or into that self-illumination channel, enable show map in viewport, go back up, and then turn ambient and diffuse to pure black. And when I do, you see the material baked onto your object. I need to do the same thing with the baseboards. Go into the baked material, enable self-illumination, go into the self-illumination map, show standard map in viewport, go back up, change ambient and diffuse to pure black, and I'm finished. So these maps are now applied as textures to these objects. I can get rid of the lighting, I can get rid of the GI and everything else through the render scene dialog box. Let's turn off lights. I have lights turned off now. Let's turn off GI. GI is now turned off. And let's turn off color mapping by setting color mapping to linear. And also this dark multiplier needs to be set to 1 because I've already made all these previous settings are now baked in to the scene, and now this is generic linear multiply with nothing but default options. Okay, so I can go ahead and render again, and again these maps are very low quality, so this is only going to look so good, and it looks like I messed up something with the baseboards in this scene, and it was because I failed to do one step, which was change it looks like I did change the color of this. It looks like the baseboards are still blue for some reason, and I'm not really sure why. Not sure why the baseboards are blue, because I have this color set to black, unless I change something in here. Let's look at the map itself. The map itself is blue, which tells me I did something wrong when I set this up, and I'm not sure what I did wrong to get blue on this map. This texture should not be blue. This should be something else. I could literally go into Photoshop right now, and actually I will do this just to show you what you can do here to fix this. This is ideally not what you should have to do, but I'm going to change this to a black and white image. I'm going to set this to black and white, and let's change the contrast so that the things that are now gray are much brighter. Like that. And once I save this, I should see the update inside 3ds Max. And there's my update inside 3ds Max. So it's not what I intended to do, but it can still be worked with. So the problem with that is, well, that actually is a problem, because now all the shadows that I had previously put in there are now wiped out. So that actually was not the solution that I needed. So I missed the step at some point doing these baseboards, but I can do the baseboards again. I can just select the baseboards right now and handle them individually as by themselves. But needless to say, here's my render to texture image. Now the quality that I have, or the lack of quality that I have, is solely because of the size of my map. The size of my map is going to be important for getting this detail in here, but also the size of the object. This map that I've saved, this map here that I saved for, let's go into the map for the walls object. The map that I saved for the walls object is 1000 by 1000, 1024 by 1024. And that map has to be divided so that all the pieces fit in here with a certain spacing in between. Okay, so these objects have to fit in here. If I had an object that had millions and millions of polygons, then these individual polygons placed on this map would have to be scaled down and scaled down farther and farther so that they all fit. So the point is, if I want to really fix this, or if I want to really get some good quality in this, what I could do is select this floor, just as an example, select this floor. It's a single polygon. I can separate this. I can create a new object for this individual object here. I can detach this and close out. This is sort of hard to work with when you're dealing with a lower resolution, which I'm doing right now just because of the live presentation. But needless to say, I've got an object here. I'm going to call this floor. And if I isolate this object, you can see that I still have the texture baked onto it, but if I want to retexture it and do something else, I can't really do it right now. I would really need to do this before I render and change my light settings. Right now I'd have to go back and turn on lights and do everything else. But if I render to texture this object right now, then that object, instead of being really small inside my view, which is this little area right down here, instead of it being this tiny little corner of this map, it will take up the entire map. It'll take up the entire map because this whole map, this 1024 by 1024, will be dedicated to that one polygon by itself. I'll do this. Let's do this really quickly. I only have 5 more minutes, and I want to demonstrate this because I think this is an important point. So I'm going to reopen this file, and I'm going to render to texture just this floor, but I want to separate it out first. So I select that object, go into Edit Poly, go into Polygon Subobject mode, detach this, call it floor. So I now have an object by itself, and I can select that object just by itself, select it, go into Render to Texture, 0 to open Render to Texture. I have the object selected already. Let's go ahead and bake this material. Automatic unwrap is set. Let's add a V-Ray complete map. Let's load this up in the self-illumination channel. Let's use 2048 by 2048. So that'll be a really decent quality looking map. Apply color mapping, create new baked material, blend, that's all good. Everything is set. Set it to render down here, render it out. I'm only rendering one texture now, and now notice the quality I can get in this texture because it has taken up the whole map. And if I want to do this even more, I can break this object up into smaller and smaller segments, and I can have one section here that's close to my camera take up the entire map and get some really good quality image in it. So I can zoom in farther. Now I'm at 1:1 scale, so this is the kind of quality I see. The shadows that I see now are the shadows that I will get in the baked material. Open up Material Editor. Let's load this material into the Material Editor. Baked material, let's go into this baked material, turn on self-illumination, show map and viewport, go up and set ambient and diffuse to pure black, and let's just flat out delete these lights in the scene. So I'm going to select this light, delete it. Let's select the light over here, delete that light. Let's just go into the Select Objects dialog box, select both of these lights, delete them. So now I have default viewport lighting on. Control L does nothing because I already have no lights in my scene, so I already have default viewport lighting. But I have this texture baked in, I have this shadow baked into my scene even though there is no light currently in the scene. So I need to go into Render Setup. I need to turn off lights. I already have lights turned off, but it's just force of habit. Turn off GI. Go into turn off color mapping, set exponential back to linear multiply, turn all these values back to their default value. Now when I render, the only object that will look proper will be the floor object. When I render, I see a nice quality floor object down here, and everything else is pure black, and that's exactly what I was hoping for. So this is an example of a high enough quality image that should suffice. I can render higher. I can render with higher quality settings. Remember, these were very, very low quality settings. These were with the original GI that I baked was very, very low quality, but it does the job. And finally, I can do some pretty cool stuff inside the object that I just saved, or the material or map I just saved. I can write my name out, change the size to something like that, put it right there in the center, save it. I need to save it as a TGA. Actually, if I just flatten this out, I won't have to bother doing that. I can just save. There we go. And now I should see this inside Max. There's my name showing up right there inside the viewport. And I've just created a texture, a baked texture in this scene. So that is pretty much it. Pretty simple, not too many steps. Once you do it a few times, it's like riding a bike. You don't forget. There's only about 6 or 7 settings that you need to set up by default inside the render to texture dialog box. So that pretty much does it for this class. This was, again, texture baking with 3ds Max. For more information about this class and other classes, please visit www.thecgschool.com. Again, this class will be available for download later next week, along with the support files. With that, I will say thank you for watching and see you next time.